All right, so for today's agenda, I'll just go through a quick introduction, background as far as some of the quality challenges from a modeling perspective. I'll provide a little bit of a demonstration of how we're using dashboards, the overlays, and a little bit of how the implementation would look like if we want to assess our models from a semantic perspective, and then some of the insights that we gain by applying these approaches, both from a quality perspective and from an organizational perspective. So some of the biggest challenge that we encountered was that there was no universally um, accepted framework for assessing our models from a quality perspective. There was a lot of ambiguity as far as what are the metrics that we should consider from a consistency, complexity perspective. And we couldn't find anything that relates to semantics specifically for UAF. Some of the other things that we were looking into is the interoperability. We acknowledge that none of the models are going to exist in isolation, and we need to consider the integration between other architectures, other artifacts, and other auto systems models. One of the other things that poses a significant challenge is the adoption and the culture shift as we move from all the base documentation-based approaches into the modeling-based approaches, posing, the added complexity of how do we manage quality, how do we assess our models. Uh, we have faced some resistance, and hopefully with this presentation, we'll be able to, break that barrier and make the topic a little bit more approachable. So one of the things that we did is we decided to take a very holistic approach, one that we could introduce not only best practices, governance, but also thinking about the continuous improvement of our processes and our modeling standards. One of the things that it's always talked about is our models are supposed to be the authoritative sources of truth. And if we want that to be the case, we need to put quality as the forefront, not only from a syntactical perspective, but also from a semantic perspective, one that we can check the appropriate use of the language, the domain meta model, and then all the other normative documentation. All right, so some of the goals for our project was to look beyond the syntactical from a completeness and correctness perspective, but how do we align to the domain meta model? Can we check whether our views and diagrams conform to a DMM? Are we using those elements in the appropriate way? And are we using the language effectively to communicate to our stakeholders and to all the users? Some of the other things is how do we integrate best practices from industry, internal to organization? What are some other metrics that we can standardize and we can share with the rest of the community? And then how, from a process and governance perspective, we can institute our quality program for the enterprise as a whole. We came to a paradigm. What things can we use to actually increase our quality? So none of the items in the slide here can address quality by itself. So taking a holistic approach, some of the benefits and disadvantages, specifically like for style guides. Style guides provide consistency, but they lack the formal assessment from a completeness and correctness perspective. Methodologies provide a very structured approach, but they lack the enforcement mechanism. And then from the validation suites, or what they provide syntactical check, but sometimes they fail to assess our models in a more semantical, deeper way. So one of the reasons we decided to look for a framework was to be able to integrate all these different aspects in a more cohesive manner. One of the ones that we wanted to introduce was to be able to standardize metrics, provide more structure to all validation efforts, and then also incorporate different quality dimensions. So based on the research that we were able to perform, we came across the SQL, or also known as the semi-audit quality framework. This framework right off the bat gave us um, a pretty good look about the semantic and the syntactic quality. It also gave us an opportunity to align our modeling goals with our enterprise goals. And we quickly saw that it was easy to integrate with the UAF as a whole for the enterprise. All right, so everybody's familiar with the UAF grid. So one of the things is we want to leverage something that everybody is familiar with and overlay information so that we can provide higher context from a quality perspective, and then also look into other ways of assessing our models and architectures, and we're able to communicate that with our stakeholders. So what's an overlay? So an overlay is something that we can superimpose information into existing framework, which is the UAF grid in this case. And then we're adding an extra layer from a quality perspective. So we're going to be adding the semantic and then the syntactic layer onto it. And we'll see that in an example later on. So we're using the dashboard from a UAF grid perspective. This is when we can visualize um, some of the things here is whether we're overutilizing a particular diagram or view specification, things that are underutilized from an individual model perspective, also for the enterprise as a whole. And then some of the other things that we're looking into is gathering some metrics and data, like where all the modeling is happening from a viewpoint perspective. Is the enterprise modeling more in the resource domain than the operational domain? And then how do we tie this information as respect to the defects that we find from a syntactic and semantic perspective? So one of the things that we decided to do is to visualize the data from a syntactic perspective and basically correlate all this data. Uh, so validation suites. So validation suites, it's something that is standard in Cameo, but they're not fit for purpose. One of the things that we also wanted to do is to acknowledge that models evolve over time and the requirements are different. So we go from very high level concepts to very mature operational or resource architectures, and assessing those architectural descriptions or architectures requires a different set of rules and also the stringency. So here I have an example of overlaying some of the requirements from a milestone perspective. So we have two different milestones, and we can see how the architecture is evolving. This is basically our entry and exit criterias. And here, basically what we're saying is this is the views that we require for two different milestone events. And those are tied back to what are, from an element perspective, the things that I'm going to be checking from a semantic point of view and also from a syntactic. So as we can see on the graph on the right-hand side, we can see that the number of validation rules is much more initially, and it grows through time. And also the severity of the rules also increases. So one of the things that we had to do to be able to account for what do we need at a certain point, or what are the other things that are not available from a gap perspective. So we map all the elements, these specifications, and also all the constraints. So these gave us the proper relationships to be able to map all of our defects from a UAF grid perspective. And this is where the heat maps are going to come into play. So now what I'm going to do is I'm going to deep dive into how do we define from an implementation perspective some of the rules to be able to check conformance to a DMM. And then also at a user level, what are the things that we can check to provide a little bit more fidelity and more conformance to a DMM. So we chose the strategic taxonomy because it's very straightforward and simple. One of the concerns that it's trying to address is the capability needs for the enterprise. And according to the DMM, we have capability elements and generalizations between the capability elements. As a optional feature, we can define whether the capabilities are of a certain kind, and this is optional. So from the two diagrams on the top, the first one, it's an empty diagram or view specification. That means that we're not communicating anything. This was the first step to identify whether we're using the right elements and we're conforming to the strategic taxonomy in that sense. The second view, it is conforming to the view specification where the capability count is optional. But in our case, for our enterprise, we decided we wanted to require or mandate this for traceability purposes. All right, so for us to be able to assess our architectures and more specifically the diagrams or view specifications, we had to assess the models using the API. One of the nuances, I guess from an implementation perspective, is that there's a diagram definition standard and that has its very unique features. So elements become presentation elements, and the only way to assess the diagrams is through scripting. So in this case, we're going to be defining the context, and this can be defined for all the different diagrams or view specifications. Then we try to identify the elements as they're presented in the DMM, and then afterwards, whether we have the right relationships or not. So in this case, we're able to identify empty or erroneous diagrams and whether they had the correct relationships, attributes, properties, and so on and so forth. So at the user level, we also created additional validation rules. This is where we can define different attributes or properties. In this case, we're mandating strategic, the capability kind, and we can check for those. Whether if it's null or unspecified, we're able to account for those. And then also for the kinds of relationship between the elements. In this case, whether it has an incoming or outgoing generalization, or if it doesn't have any of those relationships, we have or consider other scenarios. And if that is the case, we have defined different rules to account, I guess, for all the different possibilities. So some of the things or accomplishments that we were able to do from an enterprise perspective is we're able to identify defects in a much more structured and controlled manner. One of the first times we assessed the whole enterprise, we had over 200,000 defects. So once we basically fit for purpose all of our validation rules to account for the maturity of the models, we were able to reduce it between 45 to 47%. Now we can also say that we have a better understanding from a behavioral perspective, how the enterprise is modeling, how the enterprise is using the different view specifications. Are we being consistent between the enterprise? And what are some areas for improvement? And how can we address those issues? Could it be training or could it be additional style guides? Or what are some other ways that we can, from a quality perspective and consistency, we can improve our methods and approaches? Some of the other things too is we're able to look at the enterprise and the architectures from a macro and micro view. Where are the concentration of all our defects from whatever quality aspect we're looking into it. And other things that we were able to figure out throughout the way is we found gaps between our processes and our methodologies, things that were being prescribed, but we didn't have any guidance or validation rules in some instances. And then additionally is we want to be able to align architectures between different domains and different groups and other agencies. And one of the other things finally is we want to gain trust and confidence not only between the enterprise but also between users and stakeholders. So to conclude, the validation at the view specification level or from a domain meta model perspective can act as a safeguard. This can ensure that we're communicating effectively, we're using the domain meta model as intended, and then additionally we can remove ambiguities and be more precise about the way we communicate. And then the only thing I have here at the end is three different views of how the use of heat map will be represented based on the quality aspect that we're looking into. All right.
All right.
Any
Thank
questions?
you. We have questions.
So one question that was asked is, does model quality include the ability of the model to perform, to actually do the architecture? For example, how long it takes to open the model, or how long it takes to make a change in the model?
Not at this time, but that's something that we're looking into. I would say that we're trying to define what the complexity of models really mean. We can size model as well, and then trying to make relationship in between that.
Another question asks, where in the containment tree do you put the validation rules? How do you go include them in the model?
So for the most part, we're in a federated modeling environment. So basically it's just a project usage, and that gives you access to the different validations. And then from assessing, I guess, the enterprise, we have different models that basically uses or include all the models in the federation. So there's, I guess, different ways of accessing the rules.
And can you give some specific semantic rules that you're using in your validation suite?
I mean, I don't have any examples. That's probably something I can email the person that asked the question with more specifics.
Okay.
All right. Thank you.